Hello, everyone. My name is Johnson, and I work as a bioinformatics scientist. Welcome to my course about machine learning with R. In this course, we will be looking at several techniques for machine learning and statistical analysis, which are closely related to each other. So what is machine learning? It's a branch of computer science that involves training a machine, such as a computer, to learn from parameters and perform tasks based on learning outcomes. For example, you can ask a computer to learn from parameters describing the weather, and based on those weather parameters, predict whether there will be a thunderstorm or not. There are three main branches of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We will go into details for them in later sessions. Supervised learning deals with classification tasks using established algorithms such as neural network, support vector machine, classification tree. If you work for the bioinformatics industry, you are probably also familiar with the method called PAMR. A simple example of supervised learning is getting the computer to classify animals into, say, mammals or reptiles based on several parameters such as their body temperature during the day and during the night, where their natural habitats are, what do they eat. Another example is to classify tumors based on DNA and RNA gene expression data. We will talk more during next session. Very important to supervised learning is this thing called confusion matrix. This is an example of a confusion matrix. It is used for evaluating how good your predictions are. So let's say, for example, in this case, we have 6 brain cancers correctly classified as brain cancers. We also have 2 brain cancer cases misclassified as kidney stone. We also have 6 cases of colorectal cancer correctly classified, 15 cases of kidney stone classified correctly, 2 cases of lung cancer misclassified as kidney stone. So all the diagonal entries indicate the correctly classified objects. Entries anywhere else other than the diagonal entries indicate misclassification. And from there, you can get a measure of how accurate your predictions are based on calculations of accuracy measures such as regular accuracy, G-mean, F-score, Matthew correlation coefficient, and many more such as class balanced accuracy, etc. Again, we will go into detail next time. So unsupervised learning, what is it? Unsupervised learning differs from supervised learning in that the objects do not have labels. For example, in supervised learning, you are asking the machine to look at parameters of an object from which it acquires parameters. Say, for example, you ask the machine to take a look at an object like a crocodile, just for example. In that case, you know the object you are looking at is a crocodile. However, in unsupervised learning, you do not have such labels, and you need to figure out the label by yourself. Another interesting example is to find the boundary between these two clusters based on their colors. So find the boundary between all the red circles and the yellow circles. There are several methods for this. Very famous one would be the k nearest neighbors. Again, we will go into details in later classes. Reinforcement learning deals with tasks intended for maximizing cumulative rewards without an instructor. It's usually associated and widely used in much more advanced tasks such as self-driving, and so on. We will go into detail maybe later in the course. So why do we want to study machine learning? Most likely you already have your answer before watching my videos. You all know that machine learning is especially useful for artificial intelligence. You know, AlphaGo, stuff like that. It's also true that it has a high demand for talented people nowadays. Moreover, machine learning can be applied to almost anything from aeronautical engineering to bioinformatics to financial analysis. I personally work in the medical care industry. A friend of mine who is a very awesome software engineer was very surprised when I told him that machine learning can be used for biology. Why do we want to implement machine learning methods using programming language R? Well, R is a very advanced intuitive programming language. It's accepted by people working in the statistics field over the world. Already there are many packages that you can use to play around with data, because you know machine learning is closely associated with data science, which R is a good tool for. So that's why I'm showing you guys how to implement algorithm in R. There you go, guys.